I know a lot of you have been waiting for this one, adding links to share a budget with other users. We'll interact with the clipboard, extend our queries, and appropriately use a non-live view. This video is part of a series where I'm building a Phoenix app from scratch. As always, the code is on GitHub with a link in the description. Let's get into it. The data model for the budgie app is currently pretty simple. Users have budgets, and budgets have periods and transactions. A user has access to the budgets they created, and that's it. But the plan is to add two new schemas to support this sharing feature. The first new model is a join link. Associated with the budget, this table will store a secret code that can be passed in a URL to invite others to collaborate. This can be created like any other schema with the mix Phoenix Gen schema command. I'll go into the migration that was created. Now, codes need to be unique, so we'll add a unique index on the code field. We also only want one link per budget right now, so the budget ID will also get unique indexing. Over time, the concept of code management and expiration could be interesting to pursue, but it's out of scope for today's video. We're just going to generate a link once, and it should work forever. On the schema module side, let's set up the budget relationship and update the change set. So we'll say that this belongs to a budget, and let's make it so that a budget is required and unique. We're going to remove code, and we'll treat that specially in a moment. And finally, let's make sure that we know there is a unique constraint on code. So I didn't add code to the cast array, and that's because I want these to be generated rather than being passed in. But before that, let's add the association on the budget side, saying that every budget has up to one join link. All right, so auto generation. We've already seen this for our UUID primary keys, where we set it to a binary ID type and set auto generate to true. But auto-generate is more than just a Boolean, and it can be applied to any field. If we added a function, let's say random join code, to our module, then we could set the auto-generate argument to a tuple, instructing Ecto how to populate that field. According to the Ecto documentation, this tuple needs a module, a function, and arguments. So on our field, instead of just saying it's a string, let's set the auto-generate option to the current module, __ module refers to the current module in Elixir, and then random join code is the name of the function, and we're not going to pass it any arguments. Technically, this is all we need to do to wire up this auto-generation, but of course we need to actually generate random codes. We could use anything for this, but I'm a fan of the format called Nanoid. By default, these are 21 characters long and have an incredible resistance to collisions. And even with, let's say, 8 characters, it would still take 2 million IDs in order to have a 1% probability of collision. An Elixir implementation is available on Hex, and by default it uses the strong random byte generator from the Beam's native crypto module, which internally relies on OpenSSL. It's cryptographically sound, so we can rely on it to generate unique, shareable codes that can't reasonably be guessed. So in mix.exs, let's add the new dependency. I'll add it here to the end. And run a deps.get, deps.compile, and finally restart my server with the dependency in place. Now, the primary function of the Nanoid package is generate, and it does what you'd expect. I'll go into IEX and just run it, and there's a random code. I can also generate one with a specific length if I feel like it. So let's implement random join code by just passing in nanoid.generate. Now, to actually get this running, we'll need to add this to our context module, because just like all of the other schemas in this app, we want a single interaction layer for all of the things within the tracking domain. So I want a function that, given a budget, returns the corresponding join link, and if there isn't one, then one should be created for us. Typically, I name these types of functions with the prefix ensure. So to make sure we have a join link, we use the insert function of our repo with arguments that describe what to do when there's a conflict. Conflicts occur when uniqueness constraints are violated. So the first time through, this runs as a regular insert. On subsequent calls, Postgres sees that there's already a code for this budget and just replaces the updated at field. At the end, we make sure to return what the database has stored. So let's try it out. Over in IEX, we'll grab an instance of a budget by ID, and then we can call tracking.ensureJoinLink, passing in that budget instance. We'll get back a join link with a randomly generated code value. If we take a look at the query that was run, it was just a single insert statement that includes conflict resolution instructions. And if I run this again, I'll get the same join link back with that prefix EOY. So let's make these codes actually do something. Up to this point, we've built Budgie on live views, but part of the beauty of Phoenix is that we don't have to commit to a single model. Server-generated views, just plain old views, can be constructed when interactivity and live updates aren't necessary. Written with the same Heeks template syntax, plain views use the model view controller pattern, or MVC for short. This pattern is seen in many server-side frameworks like Rails, Django, and Laravel. So let's start with our first controller. Over in Budgie Web Controllers, we'll create a new file called joincontroller.ex. And in this controller, we'll set up a single route, which will be show invitation. It takes in a code as a parameter, and will render something back. Notice that instead of live view, we are using controller. So each function in this controller that accepts a connection and a parameter map can be used to handle a route. But to do that, we need to register it in our router. Recall that our router is broken into multiple scopes, each of which references pipelines to enforce access rules and apply different types of processing. The scope at the bottom doesn't require that the user is signed in, but loads the user if there is one. Since we won't know whether the recipient of a link has already signed in, let's put our new view here. So I'll add it just below this delete. And unlike our live views, this route starts with a get, referring to the HTTP verb that the handler should be called for. GET requests are what happens when a URL is opened in a browser by default, so this is perfect. So let's go over to our browser and open up that join link. And we've gotten an error. It says that no show invitation template was defined for join HTML, and that module doesn't exist. It turns out that since Phoenix 1.7, a special convention should be followed for HTML views. By default, Phoenix looks for a module matching the name of the controller with HTML at the end. Just like this page controller has a page HTML module, we need a join HTML module. This also paves the way for JSON APIs, which would be served from modules like join.json.ex. So let's create the join HTML file in the controllers directory. And most of their implementations look exactly like this. They use a macro called embed templates to describe where the Heeks templates for the view live. And with that ceremony out of the way, we can finally create the Heeks template and get something rendering. So I'll create a new template in the join HTML directory, and it'll be called showinvitation.html.heeks. And let's just drop a hello world in there and also render the code value. If I go back to the page, now I can see that hello world and the code value that came in as a URL parameter. By the way, the code value comes from the render call in the controller. So any arguments that are passed here are considered assigns, just like the ones that we have in live views. Let's make this view actually do something interesting. I'll replace the template with one that shows information about the budget being shared. So in our template, let's just say, here's the name of the budget's creator, here's the name of the budget, and a description if there is a description. This template assumes that we have a budget assigned with the creator preloaded, which we clearly don't yet. In fact, we don't even have a way to look up a budget by a code. So let's imagine what that will look like and then build up to it. In our controller, instead of just rendering the code itself, let's make it a little bit more complicated. What we'll want to do is grab the budget by the join code, preloading that creator, and if we find a result, let's render the page. Otherwise, redirect to the main page and say budget not found. We'll do this in a function called getBudgetByJoinCode instead of the normal getBudget that is for the scenario where you have an ID. If we wanted to add special guardrails or queries when something comes in as a code, it's nice to have one place to put it. So by only working with join codes, we won't accidentally mix up codes and IDs. So let's add this function to our tracking module. Recall that the tracking module already has a robust budget query function that has multiple criteria like the user and the preload. If I added a new function, getBudgetByJoinCode, that sets a criterion of join link code, then we can add support for that criterion pretty easily in the budget query method, following the association to a join link and matching where that code equals the code that was provided. And now, if I refresh the invitation page, I can see the budget's owner and the budget's name, all just by a code. I could even do this in an incognito tab. Of course, there's some value in knowing who's signed in. Just like in LiveView, the signed in user is available in the current user assigned value. Instead of being housed on socket, it is housed on the connection, or con. And since people typically land on pages like this from another app, maybe it's a messenger or their email client, it's important for users with multiple accounts to know how they're accepting an invitation. In the template, we can use current user to add a hint for the user that this is the email they'll be joining with. And it'll show up right here, but in that incognito window, we won't be showing anything. In fact, we should let them know that they'll need to make an account first. So we'll add this just below the current user, where if there is no user, you'll have to create an account or sign in to collaborate. We'll come back to this UI in a little bit and make it actually work, but there's a more pressing matter. How should we represent a user's association with a budget once they do join? Let's revisit the app's data model once again. We can store the association between a user and a budget in a new table. I'll call it budget collaborator. If one of these records exists with a user ID and a budget ID, the user is a collaborator. Now, an argument could be made for storing collaborators in the accounts context, but the tracking context is the only domain in which the concept of a collaborator refers to a contributor on a budget. If we had another context for, let's say, shopping lists, there may be another collaborator concept in that shopping context where the same name has a different meaning based on the domain that it's in. Contexts build on a section of computer science called domain-driven design, which is a huge topic that contains many dedicated books. Anyway, let's turn this design into reality. Just like before, we'll add a new schema using Phoenix Gen schema, this time setting it to budget collaborator and passing a user ID and a budget ID. But we're going to do something a little different. Since the budget collaborator is just used to store foreign keys, and since there's no need to store more than one of these records for a given user budget combination, we can opt out of the generated primary key. So in our migration, we'll remove the ID field, and we'll set this primary key value to true on the user ID and the budget ID. As a result, this will create a composite primary key on user ID and then budget ID in that order. This functions similarly to a composite unique index with one big difference. Tables only have one primary key. Primary keys influence storage and don't require additional bookkeeping to maintain consistently quick lookups. And since our primary key will have the prefix of user ID, there's no need for an index on user ID. The primary will already cover that case. We still want one on budget ID to support lookups of collaborators on a given budget, though. And finally, for cleanup, we'll be using onDelete of delete all, which was described earlier in this series, and we'll pick these up whenever a user or a budget is deleted. I'll run Ecto migrate and show you what it looks like in the database. If I run d plus budget collaborators, this will describe in great detail the budget collaborators table. Notice that the primary key is a B tree on user ID and then budget ID, We also have our index on budget ID, and we have these foreign key relationships that will on delete cascade. That's the on delete, delete all option translated into Postgres. Now we need to make similar modifications on the Elixir side. So I'll open up the module for the collaborator. Instead of setting the primary key to this value, I'm going to just say false. And then let's use a belongs to relationship instead of these binary ID fields, indicating that the budget collaborators belong to a user and belong to a budget. Then down in our change set, let's make sure that these required fields can be set. Over in our context module, we can then add methods for ensuring and removing our collaborators. So go into tracking.ex. And at the end of this file, let's add a couple of new methods: ensure budget collaborator and remove budget collaborator. None of this should be surprising as it follows established patterns. The implementation of ensure budget collaborator is almost identical to the join link, and remove is just a delete from our repo. And now that we have this concept in place, let's wire up a new route in our join controller to actually exercise this ensure budget collaborator function. So in join controller, we'll add a new function called join, which, given a code, will look up the budget, and if the budget exists and the user isn't the creator of it, then we'll make sure they're a collaborator, and finally send that user to the budget that they should now have access to. Over in our router, let's add this to our require authenticated user scope. So if you're signed in and make a request to /join/code with the verb post, then you should be able to join the budget. Over in our invitation view, we can add a new link to that join code with a method of post, and we'll style it as a button. So when this button is clicked, the user wants to join that budget. So if I open up that link as another user, I can click the join budget button and I get a budget not found error. Let's think about why this is. In budget show live, we try and get a budget using the current user as an argument. I'm added as a collaborator, but we're currently requiring that the user argument matches the creator ID. Since I'm not the creator of the budget, I don't get access and I get kicked out. But whether you knew it or not at the time, we already prepared for this. Since all of our budget functions in the context module rely on budget query, which has a specific handler for user, we can update this to handle collaborators as well by saying that when you are binding to a user, you might be looking at collaborators or you might be looking at the creator. So if I try that link once more, I'm taken into the budget even though I didn't create it, just because I'm a collaborator. This budget will show up in our list as well because it's all in one query, so we can see the budget that I created and the budget that someone else created. We need to give a similar treatment to the other user scoped criterion, the one found in budget period query. Because if I open up a specific period, I'll get kicked out with a not found. Again, this is simple enough to fix. I can go into budget period query, and where we are loading by user, we can now also join out to collaborators looking for that creator ID or collaborator user ID. So now if I go into a budget and click on a period, I'll be able to access it. And it was that easy to give collaborators access to budgets. Establishing patterns that centralize access and query construction really pay off when new requirements come up in apps. Now here's something kind of funny. I'm already a member of Hello Budgie, but if I open up the join page, I still see this invitation. If I already have access to a budget, it's silly to see this screen. Shouldn't I just be taken directly to the budget if I open up that join link? This is simple enough to implement with a little bit of conditional logic. So over in join controller, in our show invitation method, let's replace it with something a little bit smarter. If the budget's not found, we're still going to just redirect to the root. If the current user is the creator of the budget, let's just take the user straight to that budget. And similarly, if they're already one of the collaborators, send them to the budget. But if none of these things are true, then let's show them that invitation screen. So if I come over here and open up that link as someone who's already a collaborator, I'll just be taken straight to the budget, redirecting very quickly. And if I'm signed out, then I'm taken to that invitation page. If I'm signed out and I click on join, I'll be taken to the login. And here, if I create a new account or sign in as yet another person, then I'm just taken to the root. It forgot that I was trying to join at all. Now, this redirect to the sign-in page was required because the post handler is in the authenticated user required scope. This loss of context is one of my biggest frustrations with many apps out there. They forget what you were trying to do whenever auth is encountered, but it doesn't have to be this way. When we installed Phoenix Gen Auth, this new session value called user return to was added just for this purpose. Whenever a user session is created, like when you sign in or when you sign up, this value is consulted to figure out where to navigate. For example, this is used in password reset scenarios where, after the reset, you want to be taken to the user's settings page. And we can set this value too. Over in Join Controller, right before we do our render of the page, let's put the current path in the user return to value. Now, if I'm signed out, and visit the page, click join, and sign in, I'm taken back to the join page where I can finish my actions. Now finally, let's add a UI to actually manage the collaborators on a budget. For this, we're going to add a new route under the budget show live view. In our router, let's add a live handler for the collaborators path underneath the budget, setting the live action to collaborators. Then we'll bring back the apply action pattern to budget show live, creating a definition for when the live action is collaborators. In this situation, we want to make sure that we load the collaborators user property, and we want to make sure that we have a join link. This also requires us to name our parameters params, and I know that we're going to use the collaborators no matter what, so we'll load them here, but when we're on the collaborators page, we also want to know the user information on that association. To manage the collaborators, we're going to need a new component, and I'm going to call it collaborators dialog. It'll be very similar to our transactions dialog hosted in a modal. So under live, let's create collaborators dialog.ex, and it will be a live component that right now isn't very exciting. We'll add more functionality to justify this having its own state and being a live component soon. But first, let's drop in the HTML template. So another file right next to collaborators dialog, that's a Heeks template, and we'll drop this in. There's a lot here, but it breaks down into 3 sections. Who owns the budget, which collaborators are on it, if any, and what's that invitation URL. Just like other modals, we'll need to render this in our LiveView template when the right live action is active. So in budget show live HTML Heeks, just below our transaction modal, let's add the collaborators modal. And if I manually add /collaborators to the URL, I can see that the budget we've been working with has 2 collaborators, and I can see that join link that we've been testing out. Obviously, we need a way to get to this page. We can't expect our users to just add /collaborators to the URL that they're on. So let's add a button in the budget show live template. Just after our new transaction button, we can add a link to collaborators. So if I close this out, it says that we have 2 collaborators. It also uses a function called nGetText. This is part of the getText internationalization system integrated into Phoenix by default. Even if an app isn't fully localized, helpers like this are nice for dynamically making text plural based on numeric values. So if there was only 1 collaborator, it would say 1 collaborator versus saying some number of collaborators. Anyway, if I navigate to another budget and click on the collaborator button, everything's working as expected. Unfortunately, once someone accepts an invitation, there's no way to remove them later. So let's fix that. In our dialog, we can add a little remove collaborator button. So this will dispatch the Phoenix event remove collaborator with the value of user ID set to that collaborator's ID. This Phoenix click directive will trigger handle event in our live view in budget show live. By default, even in live components, event handlers are dispatched to the parent live view. So we'll add a handler for this event, and then I'll talk through its implementation. In budget show live, just after apply action, we'll add a handle event for remove collaborator. So first, we grab the collaborator off of the live view assigns. If they exist, we remove their budget collaborator record, forcing a reload of the collaborator list along the way. If the user removed themselves, we flash a message that they've been removed and redirect them back to the budget list. So over here, let's kick yet another out of the list. Okay, for one last thing, let's make it easier for users to grab this link down here by adding a copy button. If you haven't seen my LiveView.js video, check it out for more details on how this works. Also, know that in the upcoming LiveView 1.1 release, there will be support for inline JavaScript and components. Make sure to subscribe to this channel to get more updates like that. So over in app.js, we'll add an event listener for a custom event called copy to clipboard. Then, in our dialog, down where our URL is, we'll add a button that, when clicked, will dispatch that JavaScript event of copy to clipboard with a target of our join link text input, so we know what value to put on the clipboard. If I go over here and click copy link, then if I paste, it'll be on my clipboard. But there's no feedback when a copy occurs. And that's why I opted for a live component. It can have its own state, and in this case, we'll hold whether the link has been copied. So in addition to dispatch, let's push a copied event to our component. Notice that I set the target to @myself. Inside of a live component, this means that you don't want it to go to the view, you want it to go to the component itself. And we're imagining that we'll have a Boolean called link copied in our assigns, so let's make that happen. In collaborators dialog, instead of just passing assigns through, we'll set link copied to false by default, and whenever a copy happens, then we'll set it to true. So over in the view, copy link, and now we know that it was copied. Just like that, URLs can be copied for easy sharing. So we have an invitation system that uses plain views to provide details to the recipient. This system allows collaborators to be managed and has a little sprinkle of JavaScript to make sharing easy. A production app might benefit from the addition of user roles, which could be added on the budget collaborators model, or restricting actions to the creator of the budget. Maybe only the creator of the budget can kick collaborators. And in Phoenix 1.8, a new concept called scopes might change the way this type of code will be structured in the future. I skipped tests in this video for time's sake, but there's plenty of them in a pull request in the description. Check it out. We're nearing the end of the Budgie app journey, but there's still a little bit more to go. This has been Code and Stuff. Thanks for watching.